Write the following quadratic equations in a standard form. Ax square plus bx plus c is equal to 0. N minus 7 upon n is equal to 4. Therefore, n square minus 7 is equal to 4n. The standard form is n square minus 4n minus 7 is equal to 0. Write the following quadratic equations in a standard form. Ax square plus bx plus c is equal to 0. M square plus 5 upon m square is equal to minus 3. Therefore, m square plus 5 is equal to minus 3m square. Therefore, 4m square plus 5 is equal to 0. The standard form is 4m square plus 0m plus 5 is equal to 0. Which of the following are quadratic equations? 3y square minus 7 is equal to square root of 3y, root 3y. Therefore, 3y square minus root 3y minus 7 is equal to 0. Here, a is equal to 3, b is equal to minus root 3, c is equal to minus 7 are real numbers and a is not equal to 0. Also, the highest index of y is 2. Hence, the given equation is quadratic equation. Question number 4. State whether k is the root of given equation y square minus k minus 4 into y minus 4k is equal to 0. Solution. If k is the root of given equation, it should satisfy the equation. So, let us find out whether k satisfies the equation. Putting y is equal to k in the given equation, LHS is equal to k square minus k minus 4 into k minus 4k is equal to k square minus k square plus 4k minus 4k. Here, plus k square minus k square gets cancelled out. Similarly, plus 4k and minus 4k gets cancelled out. Therefore, it is equal to 0, which is nothing but RHS. Therefore, LHS is equal to RHS. Thus, k is the root of the given quadratic equation. Form the quadratic equation if its roots are number 1, 5 and minus 7. Solution. Let alpha is equal to 5 and beta is equal to minus 7. Therefore, alpha plus beta is equal to 5 minus 7, which is equal to minus 2. And alpha into beta is equal to 5 into minus 7, which is equal to minus 35. Therefore, the quadratic equation is x square minus alpha plus beta x plus alpha beta is equal to 0. Substituting the values, we have x square minus in bracket minus 2 into x plus minus 35 is equal to 0. Therefore, x square plus 2x minus 35 is equal to 0. This is the required quadratic equation. Determine the nature of the roots of the following equations from their discriminants. Number 1. Y square minus 4y minus 1 is equal to 0. Solution. The given equation is y square minus 4y minus 1 is equal to 0. Comparing this equation with the standard form ax square plus bx plus c is equal to 0, we get a is equal to 1, b is equal to minus 4, c is equal to minus 1. Therefore, delta is equal to b square minus 4ac is equal to minus 4 square minus 4 into 1 into minus 1 is equal to 16 plus 4, which is equal to 20. Therefore, delta is greater than 0. Hence, roots are real and unequal. Two x square plus 5 root 3x plus 16 is equal to 0. Solution. The given equation is 2x square plus 5 root 3x plus 16 is equal to 0. Comparing this equation with the standard form ax square plus bx plus c is equal to 0, we get a is equal to 2, b is equal to 5 root 3 and c is equal to 16. Therefore, delta is equal to b square minus 4ac is equal to 5 root 3 whole square minus 4 into 2 into 16 is equal to 75 minus 128, which is equal to minus 53. Therefore, delta is less than 0. Hence, roots are not real. Find the values of a, b, c for the following quadratic equations by comparing with standard form. X square plus 2x plus 1 is equal to 0. Comparing this equation with the standard form ax square plus bx plus c is equal to 0, we get a is equal to 1, b is equal to 2 and c is equal to 1. Form an equations for the following examples. The sum of a natural number x and its reciprocal is 37 upon 6. As per given condition, we have x plus 1 upon x is equal to 37 upon 6. After taking LCM of left hand side, we get x square plus 1 upon x is equal to 37 upon 6. Therefore, 6x square plus 6 is equal to 37x. Therefore, 6x square minus 37x plus 6 is equal to 0. Determine whether the given values of x is a root of given quadratic equation. X square minus x is equal to 0, where x is equal to 0. Solution. The given equation is x square minus x is equal to 0. By putting x is equal to 0 in LHS, we get LHS is equal to 0 square minus 0, which is equal to 0, is equal to RHS. Therefore, LHS is equal to RHS. Thus, equation is satisfied. Therefore, 0 is the root of given quadratic equation. Which of the following are quadratic equations? Z minus 7 upon z is equal to 4z plus 5. Multiplying on both the sides by z, we get z square minus 7 is equal to 4z square plus 5z. Therefore, 4z square plus 5z minus z square plus 7 is equal to 0. Therefore, 3z square plus 5z plus 7 is equal to 0. Here, a is equal to 3, b is equal to 5, and c is equal to 7 are real numbers, and a is not equal to 0. Also, the maximum index of z is 2. Hence, the given equation is quadratic equation. In each of the examples given below, determine whether values given against each of the quadratic equation are roots of the equation or not. 4m square minus 9 is equal to 0, where m is equal to 2, 2 upon 3, and 3 upon. By putting m is equal to 2 in LHS, we have LHS is equal to 4m square minus 9 is equal to 4 into 2 square minus 9 is equal to 4 into 4 minus 9 is equal to 16 minus 9, which is equal to 7, which is not equal to RHS. Therefore, LHS is not equal to RHS. Thus, the equation is not satisfied. Therefore, 2 is not the root of the given quadratic equation. Now, by putting m is equal to 2 upon 3 in LHS, we have LHS is equal to 4 into 2 upon 3 whole square minus 9 is equal to 4 into 4 upon 9 minus 9 is equal to 16 upon 9 minus 9. After cross multiplication, it is equal to 16 minus 81 upon 9 is equal to minus 65 upon 9, which is not equal to RHS. Therefore, LHS is not equal to RHS.
Thus, equation is not satisfied. Therefore, 2 upon 3 is not the root of the given quadratic equation.
N square plus 4n is equal to 0. And n is equal to 0 minus 2. By putting n is equal to 0 in LHS, we have LHS is equal to n square plus 4n, which is equal to 0 square plus 4 into 0 is equal to 0, which is equal to RHS. Therefore, LHS is equal to RHS. Thus, the equation is satisfied. Therefore, 0 is the root of given quadratic equation. Now, by putting n is equal to minus 2 in LHS, we have LHS is equal to minus 2 square plus 4 into minus 2 is equal to 4 minus 8 is equal to minus 4, which is not equal to RHS. Therefore, LHS is not equal to RHS. Thus, the equation is not satisfied. Therefore, minus 2 is not the root of given equation. If one root of quadratic equation x square minus 7x plus k is equal to 0 is 4, then find the value of k. Solution. It is given that x is equal to 4 is the root of the quadratic equation x square minus 7x plus k is equal to 0. Therefore, x is equal to 4 will satisfy the equation. Putting x is equal to 4 in the given equation, we have 4 square minus 7 into 4 plus k is equal to 0. Therefore, 16 minus 28 plus k is equal to 0. Therefore, minus 12 plus k is equal to 0. Therefore, k is equal to 12. Thus, the value of k is 12. Question number 5. If one root of quadratic equation kx square minus 7x plus 12 is equal to 0 is 3, then find the value of k. Solution. It is given that x is equal to 3 is the root of given quadratic equation, which means that it satisfies the equation. Therefore, putting x is equal to 3 in the given equation, we get k into 3 square minus 7 into 3 plus 12 is equal to 0. Therefore, 9k minus 21 plus 12 is equal to 0. 9k minus 9 is equal to 0. Therefore, 9k is equal to 9. Therefore, k is equal to 1. Thus, the value of k is 1. Find value of k for which given equation has real and equal roots. Number 1. K minus 12 into x square plus 2 into k minus 12 into x plus 2 is equal to 0. Solution. The given equation is k minus 12 into x square plus 2 into k minus 12 into x plus 2 is equal to 0. Comparing this equation with the standard form ax square plus bx plus c is equal to 0, we get a is equal to k minus 12, b is equal to 2 into k minus 12 and c is equal to 2. For real and equal roots, delta is equal to 0. Therefore, b square minus 4ac is equal to 0. Therefore, substituting the values of a, b and c, we get in square bracket 2 into, in round bracket, k minus 12 square bracket closed raised to 2 minus 4 into k minus 12 into 2 is equal to 0. Therefore, 4 into, in bracket, k square minus 24k plus 144 minus 8 into k minus 12, which is equal to 0. Therefore, 4k square minus 96k plus 576 minus 8k plus 96 is equal to 0. Therefore, 4k square minus 104k plus 672 is equal to 0. Now, dividing by 4 on both sides, we get k square minus 26k plus 168 is equal to 0. Now, factorizing 168 as minus 12 and minus 14, whose sum is equal to minus 26. Therefore, k square minus 12k minus 14k plus 168 is equal to 0. Taking out k common from the first two terms, we get k in the bracket k minus 12. Taking out minus 14 common from the next two terms, we have minus 14 in bracket k minus 12, which is equal to 0. Therefore, k minus 12 into k minus 14 is equal to 0. Therefore, k minus 12 is equal to 0 or k minus 14 is equal to 0. Therefore, k is equal to 12 or k is equal to 14. But k is equal to 12 is not acceptable because the coefficient of x square becomes 0. Hence, k is equal to 14. Find value of k for which given equation has real and equal roots. K square x square minus 2 into k minus 1 into x plus 4 is equal to 0. Solution. The given equation is k square x square minus 2 into k minus 1 into x plus 4 is equal to 0. Comparing this given equation with ax square plus bx plus c is equal to 0, we get a is equal to k square, b is equal to minus 2 into k minus 1 and c is equal to 4. Now, delta is equal to b square minus 4ac. Substituting the values of a, b and c, we get delta is equal to, in square bracket, minus 2 into k minus 1 square bracket closed whole square minus 4 into k square into 4 is equal to minus 2 square into k minus 1 whole square minus 16k square is equal to 4 into k square minus 2k plus 1 minus 16k square is equal to 4k square minus 8k plus 4 minus 16k square, which is equal to minus 12k square minus 8k plus 4. Since the roots of the given quadratic equation are real and equal, so delta must be 0. Therefore, minus 12k square minus 8k plus 4 is equal to 0. Taking out minus 4 common, we get minus 4 in bracket 3k square plus 2k minus 1 is equal to 0. Therefore, 3k square plus 2k minus 1 is equal to 0. Therefore, 3k square plus 3k minus k minus 1 is equal to 0. Taking out 3k common from the first two terms, we have 3k in bracket k plus 1. And taking out minus 1 common from the next two terms, we have minus 1 in bracket k plus 1 is equal to 0. Therefore, k plus 1 into 3k minus 1 is equal to 0. Therefore, k plus 1 is equal to 0 or 3k minus 1 is equal to 0. Therefore, k is equal to minus 1 or 3k is equal to 1. Therefore, k is equal to minus 1 or k is equal to 1 upon 3. Solve the following quadratic equations by completing square. P square minus 12p plus 32 is equal to 0. Solution. The given equation is p square minus 12p plus 32 is equal to 0. Shifting the constant term on the right hand side, we have p square minus 12p is equal to minus 32. Now, we will make LHS a perfect square by using third term is equal to half into coefficient of p whole bracket square is equal to half into minus 12 whole bracket square. 2 ones are 2 minus 6 are minus 12. And minus 6 whole square is equal to 36. Adding 36 on both the sides, we get p square minus 12p plus 36 is equal to minus 32 plus 36. Therefore, p square minus 12p plus 36 is equal to 4. Now, here p square minus 12p plus 36 on the left hand side is the square of p minus 6 and 4 is the square of 2. Therefore, p minus 6 whole square is equal to 2 square. Taking square root on both the sides, we get p minus 6 is equal to plus or minus 2. Therefore, p minus 6 is equal to 2 or p minus 6 is equal to minus 2. Therefore, p is equal to 2 plus 6, which is equal to 8, or p is equal to minus 2 plus 6, which is equal to 4. Therefore, 8 and 4 are the roots of given quadratic equation. Solve the following quadratic equations by completing square. X into in bracket x minus 1 is equal to 1. Solution. The given equation is x into in bracket x minus 1 is equal to 1. Opening the bracket, we have x square minus x is equal to 1. Now, we will make LHS a perfect square by using third term is equal to half into coefficient of x whole bracket square is equal to half into minus 1 whole bracket square is equal to minus 1 upon 2 whole square, which is equal to 1 upon 4. Now adding 1 upon 4 on both the sides, we get x square minus x plus 1 upon 4 is equal to 1 plus 1 upon 4. Therefore, x square minus x plus 1 upon 4 is equal to 5 upon 4. Now, x square minus x plus 1 upon 4 on left hand side is the square of x minus 1 upon 2. Therefore, x minus 1 upon 2 whole square is equal to root 5 upon 2 whole bracket square. Therefore, x minus 1 upon 2 is equal to plus or minus root 5 upon 2. Therefore, x is equal to 1 upon 2 plus or minus root 5 upon 2. Taking 2 as a common denominator, we have x is equal to 1 plus or minus root 5 upon 2. Therefore, x is equal to 1 plus root 5 upon 2, or x is equal to 1 minus root 5 upon 2. Therefore, 1 plus root 5 upon 2 and 1 minus root 5 upon 2 are the roots of the given quadratic equation. Four p square plus 7 is equal to 12p. Solution. The given equation is 4p square plus 7 is equal to 12p. After shifting the terms, we get 4p square minus 12p is equal to minus 7. Dividing both the sides by 4, we get p square minus 3p is equal to minus 7 upon 4. Now, we will make LHS a perfect square by using third term is equal to half into coefficient of p whole bracket square, which is equal to half into minus 3 whole bracket square is equal to minus 3 upon 2 whole square, which is equal to 9 upon 4. Adding 9 upon 4 on both the sides, we get p square minus 3p plus 9 upon 4 is equal to minus 7 upon 4 plus 9 upon 4. Therefore, p square minus 3p plus 9 upon 4 is equal to, taking 4 as a common denominator on right hand side, we have minus 7 plus 9 upon 4. Therefore, p square minus 3p plus 9 upon 4 is equal to 2 upon 4. Therefore, p square minus 3p plus 9 upon 4 is equal to 1 upon 2. Here, p square minus 3p plus 9 upon 4 on left hand side is the square of p minus 3 upon 2. Therefore, p minus 3 upon 2 whole square is equal to 1 upon root 2 whole square. Taking square root on both the sides, we get p minus 3 upon 2 is equal to plus or minus 1 upon root 2. Now rationalizing the denominator on right hand side, we get p minus 3 upon 2 is equal to plus or minus 1 upon root 2 into root 2 upon root 2. Therefore, p minus 3 upon 2 is equal to plus or minus root 2 upon 2. Therefore, p is equal to 3 upon 2 plus or minus root 2 upon 2. Therefore, p is equal to, taking 2 as a common denominator, we have 3 plus or minus root 2 upon 2. Therefore, p is equal to 3 plus root 2 upon 2, or p is equal to 3 minus root 2 upon 2. Therefore, 3 plus root 2 upon 2 and 3 minus root 2 upon 2 are the roots of given quadratic equation. Two n square plus 5n plus 2 is equal to 0. Solution. The given equation is 2n square plus 5n plus 2 is equal to 0. Comparing this equation with the standard form ax square plus bx plus c is equal to 0, we have a is equal to 2, b is equal to 5 and c is equal to 2. By using the formula n is equal to minus b plus or minus under root b square minus 4ac upon 2a. Putting the values of a, b and c, we get n is equal to minus 5 plus or minus 5 square minus 4 into 2 into 2 upon 2 into 2 is equal to minus 5 plus or minus under root 25 minus 16 upon 4 is equal to minus 5 plus or minus root 9 upon 4. Therefore, n is equal to minus 5 plus or minus 3 upon 4. Therefore, n is equal to minus 5 plus 3 upon 4, or n is equal to minus 5 minus 3 upon 4. Therefore, n is equal to minus 2 upon 4, which is equal to minus 1 upon 2, or n is equal to minus 8 upon 4, which is equal to minus 2. Thus, minus 2 and minus 1 upon 2 are the roots of given quadratic equation. Three q square is equal to 2q plus 8. Solution. The given equation is 3q square is equal to 2q plus 8. Therefore, 3q square minus 2q minus 8 is equal to 0. Comparing this equation with the standard form ax square plus bx plus c is equal to 0, we have a is equal to 3, b is equal to minus 2, and c is equal to minus 8. Now, by using the formula q is equal to minus b plus or minus under root b square minus 4ac upon 2a. And putting the values of a, b and c, we get q is equal to minus in bracket minus 2 plus or minus under root minus 2 square minus 4 into 3 into minus 8 upon 2 into 3 is equal to 2 plus or minus under root 4 plus 96 upon 6 is equal to 2 plus or minus under root 100 upon 6 is equal to 2 plus or minus 10 upon 6. Taking out 2 common, we have q is equal to 2 in bracket 1 plus or minus 5 upon 6. 2 ones are 2 threes are 6. Therefore, q is equal to 1 plus or minus 5 upon 3. Therefore, q is equal to 1 plus 5 upon 3, or q is equal to 1 minus 5 upon 3. Therefore, q is equal to 6 upon 3, which is equal to 2, or q is equal to minus 4 upon 3. Therefore, 2 and minus 4 upon 3 are the roots of given quadratic equation. Seven p square minus 5p minus 2 is equal to 0. Solution. The given quadratic equation is 7p square minus 5p minus 2 is equal to 0. Comparing this equation with the standard form ax square plus bx plus c is equal to 0, we have a is equal to 7, b is equal to minus 5, and c is equal to minus 2. Now, by using the formula P is equal to minus B plus or minus under root B square minus 4AC upon 2A and putting the value of A, B and C, we get P is equal to minus in bracket minus 5 plus or minus under root minus 5 square minus 4 into 7 into minus 2 upon 2 into 7 is equal to 5 plus or minus under root 25 plus 56 upon 14 is equal to 5 plus or minus under root 81 upon 14 is equal to 5 plus or minus 9 upon 14. Therefore, P is equal to 5 plus 9 upon 14 or P is equal to 5 minus 9 upon 14. Therefore, P is equal to 14 upon 14, which is equal to 1, or P is equal to minus 4 upon 14, which is equal to minus 2 upon 7. Therefore, 1 and minus 2 upon 7 are the roots of given quadratic equation. If the sum of the roots of the quadratic equation is 3 and sum of their cubes is 63, find the quadratic equation. Solution. Let alpha and beta be the roots of required quadratic equation. Therefore, as per given conditions, alpha plus beta is equal to 3 and alpha cube plus beta cube is equal to 63. Now, by using the formula a cube plus b cube is equal to a plus b whole cube minus 3ab into a plus b, we get alpha plus beta whole cube minus 3 alpha into beta into alpha plus beta is equal to 63. Now, substituting the values, we get 3 cube minus 3 alpha into beta into 3 is equal to 63. Therefore, 27 minus 9 alpha into beta is equal to 63. Therefore, minus 9 alpha into beta is equal to 63 minus 27. Therefore, minus 9 alpha into beta is equal to 36. Therefore, alpha into beta is equal to 36 divided by minus 9, which is equal to minus 4. Therefore, the quadratic equation is x square minus alpha plus beta into x plus alpha beta is equal to 0. Substituting the values of alpha plus beta and alpha into beta, we get x square minus 3x plus in bracket
minus 4
is equal to 0. Therefore, x square minus 3x
minus 4
is equal to 0 is the required quadratic equation. X raised to 4 minus 3x square plus 2 is equal to 0. Solution. The given equation is x raised to 4 minus 3x square plus 2 is equal to 0. Let x square be equal to m. Therefore, m square minus 3m plus 2 is equal to 0. Splitting the middle term, we get m square minus 2m minus m plus 2 is equal to 0. Taking out m common from the first two terms, we have m in bracket m minus 2. And taking out minus 1 common from the next two terms, we have minus 1 in bracket m minus 2 is equal to 0. Therefore, m minus 2 into m minus 1 is equal to 0. Therefore, m minus 2 is equal to 0 or m minus 1 is equal to 0. Therefore, m is equal to 2 or m is equal to 1. Now, resubstituting m is equal to x square, we get x square is equal to 2 or x square is equal to 1. Taking square roots on both sides, we get x is equal to plus or minus root 2 or x is equal to plus or minus 1. Therefore, 1, minus 1, root 2 and minus root 2 are the roots of quadratic equation. The sum of the squares of two consecutive natural numbers is 113. Find the numbers. Solution. Let the two consecutive numbers be x and x plus 1. As per given condition, we have x square plus x plus 1 whole square is equal to 113. Therefore, x square plus 2x plus 1 is equal to 113. 2x square plus 2x plus 1 minus 113 is equal to 0. Therefore, 2x square plus 2x minus 112 is equal to 0. Dividing the equation by 2 on both the sides, we get x square plus x minus 56 is equal to 0. Now splitting the middle term plus x as 8x and minus 7x. We have x square plus 8x minus 7x minus 56 is equal to 0. Taking x common from the first two terms, we get x in bracket x plus 8. And taking out minus 7 common from the next two terms, we have minus 7 in bracket x plus 8 is equal to 0. Therefore, x plus 8 into x minus 7 is equal to 0. Therefore, x plus 8 is equal to 0 or x minus 7 is equal to 0. Therefore, x is equal to minus 8 or x is equal to 7. But we know that natural numbers are never negative. So, x is not equal to minus 8. Therefore, x is equal to 7. And x plus 1 is equal to 7 plus 1 is equal to 8. Therefore, the two consecutive natural numbers are 7 and 8. A natural number is greater than twice its square root by 3. Find the number. Solution. Let the natural number be x. According to the given condition, we get x is equal to 2 root x plus 3. Therefore, x minus 3 is equal to 2 root x. Squaring on both the sides, we get x minus 3 whole square is equal to 4x. Therefore, x square minus 6x plus 9 is equal to 4x. Therefore, x square minus 6x minus 4x plus 9 is equal to 0. Therefore, x square minus 10x plus 9 is equal to 0. Now, splitting the middle term minus 10x as minus 9x and minus x, we get x square minus 9x minus x plus 9 is equal to 0. Taking out x common from the first two terms, we have x in bracket x minus 9. And taking out minus 1 common from the next two terms, we have minus 1 in bracket x minus 9 is equal to 0. Therefore, x minus 9 into x minus 1 is equal to 0. Therefore, x minus 9 is equal to 0 or x minus 1 is equal to 0. Therefore, x is equal to 9 or x is equal to 1. If x is equal to 1, but x is not equal to 1, as it does not satisfy the given condition, that is, x is not equal to 2 root x plus 3. 1 is not equal to 2 root 1 plus 3. Therefore, x is equal to 9. Thus, the natural number is 9. A rectangular playground is 420 square meter. If its length is increased by 7 meters and breadth is decreased by 5 meters, the area remains the same. Find the length and breadth of the playground. Solution. Let length be L meters and breadth be B meters. According to given condition, length into breadth is equal to 420. Let this be equation number 1. Now, if the length is increased by 7 and breadth is decreased by 5 meters, the area remains the same. Therefore, we have L plus 7 into b minus 5 is equal to 420. Therefore, LB minus 5L plus 7B minus 35 is equal to 420. From equation 1, we know that LB is equal to 420. Putting this value, we get 420 minus 5L plus 7B minus 35 is equal to 420. $420 gets cancelled out on either sides, and we have minus 5L plus 7B is equal to 35. Also, from equation 1, we can derive the value for length. That is, if LB is equal to 420, then L is equal to 420 divided by B. Using this value of L, we get minus 5 into 420 upon B plus 7B is equal to 35. Therefore, minus 2100 upon B plus 7B is equal to 35. Minus 2100 plus 7B square upon B is equal to 35. Therefore, 7B square minus 2100 is equal to 35B. Therefore, 7B square minus 35B minus 2100 is equal to 0. Dividing the equation by 7 on both the sides, we get B square minus 5B minus 300 is equal to 0. Splitting the middle term, we get B square minus 20B plus 15B minus 300 is equal to 0. Now taking out B common from the first two terms, we have B in bracket B minus 20. And taking out plus 15 common from the next two terms, we have plus 15 in bracket B minus 20 is equal to 0. Therefore, B minus 20 into B plus 15 is equal to 0. Therefore, B minus 20 is equal to 0 or B plus 15 is equal to 0. Therefore, B is equal to 20 or B is equal to minus 15. But we know that breadth can never be negative. Hence, B is not equal to minus 15. Therefore, B is equal to 20 meters. Putting the value of B in equation 1, we get 20L is equal to 420. Therefore, L is equal to 420 divided by 20, which is equal to 21 meters. Thus, the length and breadth of the playground is 21 meters and 20 meters respectively.
Form the quadratic equation whose roots are the square of the sum of the roots and square of the difference of the roots of the equation. 2x square plus 2 into bracket open m plus n bracket closed into x plus m square plus n square is equal to 0. Solution. Let us consider alpha and beta be the roots of the equation. 2x square plus 2 into, in the brackets, m plus n bracket closed into x plus m square plus n square is equal to 0. Then alpha plus beta would be equal to minus 2 into m plus n upon 2, which would be equal to minus into m plus n, and alpha into beta would be equal to m square minus n square upon 2. Let's put it as 1. Now the roots of the required equation are correct. Alpha plus beta whole square and alpha minus beta whole square. Now alpha plus beta whole square plus alpha minus beta whole square would be equal to 2 into alpha square plus beta square, which is further equal to 2 into bracket open alpha plus beta whole square minus 2 into alpha beta bracket closed, which is further equal to 2 into curly brackets minus into m plus n whole square minus 2 into m square plus n square upon 2 curly brackets closed. And we can say that from 1, which is further equal to 2 into curly brackets m plus n whole square minus m square plus n square curly brackets closed. This is further equal to 2 into brackets 2 into mn bracket closed, which is equal to 4mn. Let's put it as 2. Now alpha plus beta whole square into alpha minus beta whole square is equal to alpha plus beta whole square into brackets open alpha plus beta whole square minus 4 into alpha beta bracket closed. Once we put in the values, it would be m plus n whole square into bracket open m plus n whole square minus 4 into m square plus n square upon 2 bracket closed. Now this is further equal to m plus n whole square into bracket open m plus n whole square minus 2 into m square plus n square bracket closed. This is further equal to m plus n whole square into minus m square plus 2 into m into n minus n square. Well, it is further equal to minus m plus n whole square into m minus n whole square. So it is equal to minus into m square plus n square whole square. Let's put it as 3. Now the required equation is x square minus sum of the roots into x plus product of the roots is equal to 0. So from 2 and 3 we can say x square minus 4mnx minus m square minus n square whole square is equal to 0. Therefore, the required quadratic equation is x square minus 4mnx minus m square minus n square whole square is equal to 0.
if the roots of quadratic equation ax square plus cx plus c is equal to 0 are in the ratio p is to q, show that root p upon q plus root q upon p plus root c upon a is equal to 0. Solution. Let alpha and beta be the roots of ax square plus bx plus c is equal to 0. Therefore, alpha plus beta is equal to minus c upon a, and alpha into beta is equal to c upon a. Therefore, root alpha into root beta is equal to root c upon a. Let this be equation number 1. Also, alpha plus beta upon alpha into beta is equal to minus c upon a divided by c upon a, which is equal to minus 1. Therefore, alpha plus beta is equal to minus alpha beta. Let this be equation number 2. Now, it is given that alpha upon beta is equal to p upon q. Therefore, root alpha upon root beta is equal to root p upon q. Let this be equation number 3. By invertendo, we have root beta upon root alpha is equal to root q upon p. Let this be equation number 4. Now, from equation 3 and 4, we have root p upon q plus root q upon p is equal to root alpha upon root beta plus root beta upon root alpha, which is equal to alpha plus beta upon root alpha into beta. Now, from equation 2, we know that alpha plus beta is equal to minus alpha beta divided by root alpha beta. Rationalizing the denominator, that is, by multiplying root alpha into beta to the numerator and denominator, we get is equal to minus root alpha into beta. Therefore, root p upon q plus root q upon p is equal to minus root c upon a from equation 1. Therefore, root p upon q plus root q upon p plus root c upon a is equal to 0.
Find the value of p if the equations 3x square minus 2x plus p is equal to 0 and 6x square minus 17x plus 12 is equal to 0 have a common root. Solution. Consider the equation 6x square minus 17x plus 12 is equal to 0. Factorizing by splitting the middle term, we get 6x square minus 9x minus 8x plus 12 is equal to 0. Therefore, taking out 3x common from the first two terms, we have 3x in bracket 2x minus 3. And taking out minus 4 common from the next two terms, we have minus 4 in bracket 2x minus 3 is equal to 0. Therefore, 2x minus 3 into 3x minus 4 is equal to 0. Therefore, 2x minus 3 is equal to 0 or 3x minus 4 is equal to 0. Therefore, 2x is equal to 3 or 3x is equal to 4. Therefore, x is equal to 3 upon 2 or x is equal to 4 upon 3. If x is equal to 3 upon 2 is the common root of both the equations, then x is equal to 3 upon 2 should satisfy the equation 3x square minus 2x plus p is equal to 0. Putting x is equal to 3 upon 2 in this equation, we get 3 into 3 upon 2 whole square minus 2 into 3 upon 2 plus p is equal to 0. Therefore, 3 into 9 upon 4 minus 3 upon 1 plus p is equal to 0. Therefore, 27 upon 4 minus 3 upon 1 plus p is equal to 0. Therefore, 27 minus 12 upon 4 plus p is equal to 0. Therefore, 15 upon 4 plus p is equal to 0. Therefore, p is equal to minus 15 upon 4. Similarly, if x is equal to 4 upon 3 is the common root of both the equations, then x is equal to 4 upon 3 should satisfy the equation 3x square minus 2x plus p is equal to 0. Therefore, putting x is equal to 4 upon 3 in this equation, we get 3 into 4 upon 3 whole square minus 2 into 4 upon 3 plus p is equal to 0. Therefore, 3 into 16 upon 9 minus 8 upon 3 plus p is equal to 0. Therefore, 48 upon 9 minus 8 upon 3 plus p is equal to 0. Taking LCM, we get 48 minus 24 upon 9 plus p is equal to 0. Therefore, 24 upon 9 plus p is equal to 0. Therefore, p is equal to minus 24 upon 9. 3 8s are 24, 3 3s are 9. Therefore, p is equal to minus 8 upon 3. Therefore, p is equal to minus 15 upon 4 or p is equal to minus 8 upon 3.
Nine into in bracket x square plus 1 upon x square minus 3 in bracket x minus 1 upon x minus 20 is equal to 0. Solution. The given equation is 9 into in bracket x square plus 1 upon x square minus 3 into in bracket x minus 1 upon x minus 20 is equal to 0. We know that x square plus 1 upon x square is equal to x minus 1 upon x whole square plus 2. Putting this value, we get 9 into in square bracket x minus 1 upon x whole square plus 2 minus 3 in bracket x minus 1 upon x minus 20 is equal to 0. Let x minus 1 upon x be equal to m. Therefore, we have 9 in bracket m square plus 2 minus 3m minus 20 is equal to 0. Therefore, 9m square plus 18 minus 3m minus 20 is equal to 0. Therefore, 9m square minus 3m minus 2 is equal to 0. Splitting the middle term, we get 9m square minus 6m plus 3m minus 2 is equal to 0. Taking out 3m common from the first two terms, we have 3m in bracket 3m minus 2. And taking out plus 1 common from the next two terms, we have plus 1 in bracket 3m minus 2 is equal to 0. Therefore, 3m minus 2 into 3m plus 1 is equal to 0. Therefore, 3m minus 2 is equal to 0 or 3m plus 1 is equal to 0. But we know that m is equal to x minus 1 upon x. Putting this value, we get 3 in bracket x minus 1 upon x minus 2 is equal to 0. Or 3 in bracket x minus 1 upon x plus 1 is equal to 0. Therefore, 3x square minus 3 minus 2x is equal to 0. Or 3x square minus 3 plus x is equal to 0. For equation 3x square minus 2x minus 3 is equal to 0, we have a is equal to 3, b is equal to minus 2 and c is equal to minus 3. By using formula x is equal to minus b plus or minus under root b square minus 4ac upon 2a. Putting the values of a, b and c, we get x is equal to minus in bracket minus 2 plus or minus under root minus 2 square minus 4 into 3 into minus 3 upon 2 into 3 is equal to 2 plus or minus under root 4 plus 36 upon 6 is equal to 2 plus or minus root 40 upon 6 is equal to 2 plus or minus 2 root 10 upon 6. Taking out 2 common, we get x is equal to 2 in bracket 1 plus or minus root 10 upon 6. 2 ones are 2, 2 threes are 6. Therefore, x is equal to 1 plus or minus root 10 upon 3. Now, for equation 3x square plus x minus 3 is equal to 0, we have a is equal to 3, b is equal to 1 and c is equal to minus 3. By using formula, we have x is equal to minus b plus or minus root b square minus 4ac upon 2a. Putting the values of a, b and c, we get x is equal to minus 1 plus or minus under root 1 square minus 4 into 3 into minus 3 upon 2 into 3. Therefore, x is equal to minus 1 plus or minus root 1 plus 36 upon 6. Therefore, x is equal to minus 1 plus or minus root 37 upon 6. Therefore, 1 plus root 10 upon 6, 1 minus root 10 upon 6, minus 1 plus root 37 upon 6, and minus 1 minus root 37 upon 6 are the roots of given equation. Twelve into x square plus 1 upon x square minus 56 into x plus 1 upon x plus 89 is equal to 0. Solution. The given equation is 12 into x square plus 1 upon x square minus 56 into x plus 1 upon x plus 89 is equal to 0. We know that x square plus 1 upon x square is equal to x plus 1 upon x whole square minus 2. Therefore, putting this value, we get 12 in square bracket x plus 1 upon x whole square minus 2 minus 56 into in bracket x plus 1 upon x plus 89 is equal to 0. Let x plus 1 upon x be equal to m. Therefore, 12m square minus 24 minus 56m plus 89 is equal to 0. Therefore, 12m square minus 56m plus 65 is equal to 0. Splitting the middle term, we get 12m square minus 30m minus 26m plus 65 is equal to 0. Taking out 6m common from the first two terms, we have 6m in bracket 2m minus 5. Now taking out minus 13 common from the next two terms, we have minus 13 in bracket 2m minus 5 is equal to 0. Therefore, 2m minus 5 into 6m minus 13 is equal to 0. Therefore, 2m minus 5 is equal to 0 or 6m minus 13 is equal to 0. But we know that m is equal to x plus 1 upon x. Putting this value, we get 2 into in bracket x plus 1 upon x minus 5 is equal to 0. Or 6 into in bracket x plus 1 upon x minus 13 is equal to 0. After solving the brackets, we get 2x square minus 5x plus 2 is equal to 0, or 6x square minus 13x plus 6 is equal to 0. Now for the equation 2x square minus 5x plus 2 is equal to 0. Splitting the middle term, we get 2x square minus 4x minus x plus 2 is equal to 0. Taking out 2x common from the first two terms, we have 2x in bracket x minus 2, and taking out minus 1 common from the next two terms, we have minus 1 in bracket x minus 2 is equal to 0. Therefore, x minus 2 into 2x minus 1 is equal to 0. Therefore, x minus 2 is equal to 0, or 2x minus 1 is equal to 0. Therefore, x is equal to 2, or x is equal to 1 upon 2. Now, for equation 6x square minus 13x plus 6 is equal to 0, splitting the middle term, we get 6x square minus 9x minus 4x plus 6 is equal to 0. Taking out 3x common from the first two terms, we get 3x in bracket 2x minus 3, and taking out minus 2 common from the next two terms, we have minus 2 in bracket 2x minus 3 is equal to 0. Therefore, 2x minus 3 into 3x minus 2 is equal to 0. Therefore, 2x minus 3 is equal to 0, or 3x minus 2 is equal to 0. Therefore, x is equal to 3 upon 2, or x is equal to 2 upon 3. Therefore, 2, 1 upon 2, 3 upon 2 and 2 upon 3 are the roots of given equation. Two into y square minus 6y whole square minus 8 into y square minus 6y plus 3 minus 40 is equal to 0. Solution. The given equation is 2 into y square minus 6y whole square minus 8 into y square minus 6y plus 3 minus 40 is equal to 0. Let y square minus 6y be equal to m. Therefore, we have 2m square minus 8m minus 24 minus 40 is equal to 0. Therefore, 2m square minus 8m minus 64 is equal to 0. Dividing the equation by 2 on both sides, we get m square minus 4m minus 32 is equal to 0. Splitting the middle term, we get m square minus 8m plus 4m minus 32 is equal to 0. Taking out m common from the first two terms, we have m in bracket m minus 8, and taking out plus 4 common from the next two terms, we have plus 4 in bracket m minus 8 is equal to 0. Therefore, m minus 8 into m plus 4 is equal to 0. Therefore, m minus 8 is equal to 0 or m plus 4 is equal to 0. But we know that m is equal to y square minus 6y. Putting this value, we get y square minus 6y minus 8 is equal to 0, or y square minus 6y plus 4 is equal to 0. For the equation y square minus 6y minus 8 is equal to 0, we have a is equal to 1, b is equal to minus 6, and c is equal to minus 8. By using formula y is equal to minus b plus or minus under root b square minus 4ac upon 2a. Therefore, y is equal to minus in bracket minus 6 plus or minus under root minus 6 square minus 4 into 1 into minus 8 upon 2 into 1. Therefore, y is equal to 6 plus or minus under root 36 plus 32 upon 2. Therefore, y is equal to 6 plus or minus root 68 upon 2. Therefore, y is equal to 6 plus or minus 2 root 17 upon 2. Taking out 2 common, we get y is equal to 2 in bracket 3 plus or minus root 17 upon 2. Here 2 gets cancelled out in the numerator and denominator, and we get y is equal to 3 plus or minus root 17. Now for the equation y square minus 6y plus 4 is equal to 0, we have a is equal to 1, b is equal to minus 6, and c is equal to 4. Therefore, by using formula y is equal to minus b plus or minus root b square minus 4ac upon 2a. We have y is equal to minus in bracket minus 6 plus or minus under root minus 6 square minus 4 into 1 into 4 upon 2 into 1. Therefore, y is equal to 6 plus or minus under root 36 minus 16 upon 2. Therefore, y is equal to 6 plus or minus root 20 upon 2. Therefore, y is equal to 6 plus or minus 2 root 5 upon 2. Taking out 2 common, we get y is equal to 2 in bracket 3 plus or minus root 5 upon 2. Here 2 gets cancelled out in the numerator and denominator, and we get y is equal to 3 plus or minus root 5. Therefore, 3 plus root 17, 3 minus root 17, 3 plus root 5 and 3 minus root 5 are the roots of given equation. A man riding on bicycle covers a distance of 60 kilometers in a direction of wind and comes back to its original position in 8 hours. If the speed of the wind is 10 kilometers per hour, find the speed of bicycle. Solution. Let the speed of the bicycle be x kilometer per hour. The speed of the wind is equal to 10 kilometers per hour. Reason given. Now, in the direction of wind, speed will be x plus 10 kilometer per hour, while its speed against the wind will be x minus 10 kilometer per hour. Now, by using the formula distance upon speed is equal to time, we have 60 upon x plus 10 plus 60 upon x minus 10 is equal to 8. Therefore, 60 into x minus 10 plus 60 into x plus 10 divided by x plus 10 into x minus 10 is equal to 8. Taking out 60 common, we get 60 in bracket x minus 10 plus x plus 10 divided by x plus 10 into x minus 10 is equal to 8. Here, in the numerator, minus 10 and plus 10 gets cancelled out. Therefore, we have 60 into 2x divided by x square minus 100 is equal to 8. Therefore, 120x is equal to 8 into in bracket x square minus 100. Therefore, 120 upon 8 into x is equal to x square minus 100. Therefore, 15x is equal to x square minus 100. After shifting 15x, we get x square minus 15x minus 100 is equal to 0. Now, factorizing by splitting the middle term, we get x minus 20 into x plus 5 is equal to 0. Therefore, x minus 20 is equal to 0 or x plus 5 is equal to 0. Therefore, x is equal to 20 or x is equal to minus 5. But we know that speed cannot be negative. Therefore, x is not equal to minus 5. Therefore, x is equal to 20. Thus, the speed of the bicycle is 20 km per hour. A car covers a distance of 240 kilometers with some speed. If the speed is increased by 20 km per hour, it will cover the same distance in 2 hours less. Find the speed of the car. Solution. Let the speed of the car be x km per hour. Now, using the formula, distance upon speed is equal to time. From given condition, we have 240 upon x minus 240 upon x plus 20 is equal to 2. Taking out 240 common, we have 240 in square bracket 1 upon x minus 1 upon x plus 20 is equal to 2. Taking LCM of the terms in square brackets, we have 240 into in square bracket x plus 20 minus x upon x square plus 20x is equal to 2. Here, plus x and minus x gets cancelled out. Therefore, we have 240 into 20 upon x square plus 20x is equal to 2. Therefore, 4800 is equal to 2x square plus 40x. Therefore, 2x square plus 40x minus 4800 is equal to 0. Now, dividing by 2 on both sides, we get x square plus 20x minus 2400 is equal to 0. By splitting the middle term, we have x square plus 60x minus 40x minus 2400 is equal to 0. Now, taking out x common from the first two terms, we have x in bracket x plus 60, and taking out minus 40 common from the next two terms, we have minus 40 in bracket x plus 60 is equal to 0. Therefore, x plus 60 into x minus 40 is equal to 0. Therefore, x plus 60 is equal to 0 or x minus 40 is equal to 0. Therefore, x is equal to minus 60 or x is equal to 40. We know that speed cannot be negative. Therefore, x cannot be equal to minus 60. Therefore, x is equal to 40. Therefore, speed of the car is 40 km per hour. An express train takes 30 minutes less for a journey of 440 km. If its usual speed is increased by 8 km per hour, find its usual speed. Solution. Let the usual speed of express train be x km per hour. Therefore, applying the formula, distance upon speed is equal to time. We have 440 upon x minus 440 upon x plus 8 is equal to 1 upon 2. Here, half hour is nothing but equal to 30 minutes. Therefore, taking out 440 common, we have 440 into in square bracket 1 upon x minus 1 upon x plus 8 is equal to 1 upon 2. Therefore, 440 into in square bracket x plus 8 minus x upon x square plus 8x is equal to 1 upon 2. In the square bracket, plus x and minus x gets cancelled out, and we have 440 into 8 upon x square plus 8x is equal to 1 upon 2. Therefore, 3520 upon x square plus 8x is equal to 1 upon 2. Therefore, x square plus 8x is equal to 7040. Therefore, x square plus 8x minus 7040 is equal to 0. Now, splitting the middle term, we have x square plus 88x minus 80x minus 7040 is equal to 0. Taking out x common from the first two terms, we have x in bracket x plus 88 and taking out minus 80 common from the next two terms, we have minus 80 in bracket x plus 88 is equal to 0. Therefore, x plus 88 into x minus 80 is equal to 0. Therefore, x plus 88 is equal to 0 or x minus 80 is equal to 0. Therefore, x is equal to minus 88 or x is equal to 80. Here, x cannot be equal to minus 88 as speed cannot be negative. Therefore, we have x is equal to 80. Therefore, usual speed of the express train is 80 kilometers per hour. Around a square pool, there is a footpath of width 2 cm. If the area of footpath is 5/4 times that of pool, find the area of the pool. Solution. Let the side of the square pool be x meters. Therefore, its area will be equal to x square meters. With the footpath of 2 meters around the pool, side becomes x plus 2, which is equal to x plus 4 meters. Therefore, area of footpath is equal to x plus 4 whole square minus x square is equal to x square plus 8x plus 16 minus x square. Here, plus x square and minus x square gets cancelled out. Therefore, area of footpath is equal to 8x plus 16 square meters. Now, area of footpath is 5/4 times the area of pool. Therefore, we have 8x plus 16 is equal to 5/4 into x square. Multiplying both the sides by 4, we get 32x plus 64 is equal to 5x square. Therefore, 5x square minus 32x minus 64 is equal to 0. Now, factorizing by splitting the middle term, we get 5x square minus 40x plus 8x minus 64 is equal to 0. Removing 5x common from the first two terms, we have 5x in bracket x minus 8. Taking out plus 8 common from the next two terms, we have plus 8 in bracket x minus 8 is equal to 0. Therefore, x minus 8 into 5x plus 8 is equal to 0. Therefore, x minus 8 is equal to 0 or 5x plus 8 is equal to 0. Therefore, x is equal to 8 or x is equal to minus 8/5. Here, x cannot be equal to minus 8/5 as the side of pool cannot be negative. Therefore, we have x is equal to 8. That is, side of a square pool is 8 meters. Therefore, area of square pool is equal to 8 square, which is equal to 64 square meters. Therefore, area of square pool is 64 square meters. A man travels by boat 36 km down a river and back in 8 hours. If the speed of his boat in still water is 12 km per hour, find the speed of the river current. Solution. The speed of the boat in still water is 12 km per hour. Let the speed of the river current be x km per hour. Therefore, the speed of the boat in downstream is equal to 12 plus x km per hour, and the speed of the boat in upstream is equal to 12 minus x km per hour. Now, according to the given condition, using the formula distance upon speed is equal to time, we get 36 upon 12 plus x plus 36 upon 12 minus x is equal to 8. Taking out 36 common, we have 36 into, in square bracket, 1 upon 12 plus x plus 1 upon 12 minus x is equal to 8. Therefore, 1 upon 12 plus x plus 1 upon 12 minus x is equal to 8 upon 36. 4 2s are 8, 4 9s are 36. Therefore, 12 minus x plus 12 plus x upon 12 plus x into 12 minus x is equal to 2 upon 9. Here, minus x and plus x gets cancelled out. Therefore, we have 24 upon 12 square minus x square is equal to 2 upon 9. Therefore, 24 upon 144 minus x square is equal to 2 upon 9. Dividing by 2 on both sides, we get 12 upon 144 minus x square is equal to 1 upon 9. Therefore, 108 is equal to 144 minus x square. Therefore, x square is equal to 144 minus 108. Therefore, x square is equal to 36. Taking square root on both sides, we get x is equal to plus or minus 6. But x is not equal to minus 6, as speed of a stream cannot be negative. So x is equal to 6. Thus, the speed of river current is 6 km per hour. A businessman bought some items for rupees 600. Keeping 10 items for himself, he sold the remaining items at a profit of rupees 5 per item. From the amount received in this deal, he could buy 15 more items. Find the original price of each item. Solution. Let the original purchase price of each item be rupees x. Hence, number of items can be purchased for rupees 600 is equal to 600 upon x. Now, keeping 10 items for himself, number of items sold will be equal to 600 upon x minus 10. Now, it is given that there is 5 rupees profit on each item. Therefore, selling price of each item will be equal to x plus 5 rupees. Therefore, total amount obtained is equal to number of items into selling price of each item, which is equal to 600 upon x minus 10 into x plus 5. Let this be equation number 1. Now, from this selling price, if we can get 15 items more, that is 600 upon x plus 15 items can be obtained at the original rate of rupees x. Therefore, total amount should be paid is equal to number of items into original rate of item, which is equal to 600 upon x plus 15 into x. Let this be equation number 2. Now, from equation 1 and 2, we get (600 upon x minus 10 into x plus 5) is equal to 600 upon x plus 15 into x. Therefore, 600 minus 10x into x plus 5 upon x is equal to 600 plus 15x. Therefore, 600x plus 3000 minus 10x square minus 50x is equal to x into 600 plus 15x. Therefore, 600x plus 3000 minus 10x square minus 50x is equal to 600x plus 15x square. Here, 600x gets cancelled out on either sides, and we have 15x square plus 10x square plus 50x minus 3000 is equal to 0. Therefore, 25x square plus 50x minus 3000 is equal to 0. Dividing by 25 on both sides, we get x square plus 2x minus 120 is equal to 0. Factorizing by splitting the middle term, we get x square plus 12x minus 10x minus 120 is equal to 0. Taking out x common from the first two terms, we have x into in bracket x plus 12, and taking out minus 10 common from the next two terms, we have minus 10 into in bracket x plus 12 is equal to 0. Therefore, x plus 12 into x minus 10 is equal to 0. Therefore, x plus 12 is equal to 0, or x minus 10 is equal to 0. Therefore, x is equal to minus 12, or x is equal to 10. But x cannot be equal to minus 12, as price cannot be negative. Therefore, x is equal to 10. Thus, the original price of each item is rupees 10.